Please like, share my videos and subscribe my channel if you have not already subscribed. Thank you. 10 questions, 10 numerical value questions were given in the JEE Main examination held in January 2024 session from the topic Definite Integrals from the chapter Integral Calculus. In this video, we will discuss the first 4 questions of these session of examinations. This question has appeared in the JEE Main exam held on 27 January 2024 in the second shift. The given question is, let f of x is equal to the integral 0 to x g of t log of 1 minus t by 1 plus t to the base e with respect to t, where g is a continuous odd function. If the integral minus pi by 2 to pi by 2 of in brackets f of x plus x square cos x by 1 plus e power x with respect to x is equal to pi by alpha whole square minus alpha, then alpha is equal to, right? So we are given a function f of x in terms of a g of t, where g is a continuous function. Now let's now discuss the solution of the problem in detail. Now if g is an odd function, what could be the f? Is f an even function or odd function or neither? Okay, we'll test that. F of minus x is equal to, so it will be integral 0 to minus x g of t log of 1 minus t by 1 plus t to the base e with respect to t, right? Now substitute t is equal to minus u. If t is minus u, dt will be minus du, and these limits of the integration will change. T is equal to 0 will imply u is equal to 0. T is equal to minus x will imply u is equal to x. Alright. Now this definite integral, the limits will change. It will be integral 0 to u g of t minus u log of 1 minus t will be 1 plus u by 1 plus t is 1 minus u to the base e, dt is minus du. Now with this minus, we have written this as minus of log of 1 plus u by 1 minus u as log of 1 minus u by 1 plus u. So this we have reverted, taking minus into account. Now g is an odd function, therefore g of minus u is g of u. That is, g of minus u is minus gu. G of minus u is minus gu because g is an odd function. G is an odd function. So this will be integral, this will be minus integral 0 to x g of x log of 1 minus x by 1 plus x to the base e with respect to x. This is minus, this is none other than f of x. So f of minus x is equal to minus f of x. Therefore it is also an odd function. We continue in the next slide. So we have seen that f is an odd function. Now let us take the given integral as I. I is equal to integral minus pi by 2 to pi by 2 of in brackets f of x plus x square cos x by 1 plus e to the power of x dx. So the integral of the sum is equal to sum of their integrals, the sum of the first function, the integral of the first function plus the integral of the second function. The integral of the first function is 0 because f of x is an odd function. Because f of x is an odd function, minus pi by 2 plus pi by 2, this will be 0. So that will be equal to integral minus pi by 2 to plus pi by 2 of the second function. Right. Now we write this is 2, this is equal to, I is equal to minus pi by 2 plus pi by 2 x square cos x by 1 plus e to the power of x dx. So this, call it as 1. Now I'll show you another representation for that, for this. This is the integral here, and substitute x is equal to minus v. If you substitute x is equal to minus v, dx is equal to minus dv, and the limits will change accordingly. Then the I will be integral pi by 2 to minus pi by 2 of x square v square into cos of minus v by 1 plus e to the power of minus v, because x is equal to minus v, dx is minus dv. And this minus is taken, and we have shifted this limits from pi by 2 to minus pi by 2 to, now it will be shifted to minus pi by 2 to plus pi by 2. So that is the thing, that is what we have written. And this e to the power of minus v, we have written 1 by e to the power of v, taken the logarithm and adjust the terms. Then you will get e to the power of v into v square cos v by e to the power of v plus 1 dv. Right. So this is none other than integral minus pi by 2 plus pi by 2 e power x square cos x by e to the power of x plus 1 dx. That is I. Let's write down here. So this we have written here. This is 2. So if you add, say, you will get a numerator 1 plus e power x, and there is a new denominator 1 plus e power x, they cancel and something is coming out. So that we do in the next slide. Right. What we have, first one and the second one. Now we add these two. 1 plus 2 will give you I plus I 2I is equal to integral minus pi by 2 plus pi by 2 x square cos x by 1 plus e power x is common, and from here e power x, so in brackets 1 plus e power x, this will cancel, and you will get integral minus pi by 2 plus pi by 2 x square cos x, and x square cos x is an even function, therefore 2 times half integral 0 to pi by 2 x square cos x dx. Right. So 2 cancels, and I is equal to integral 0 to pi by 2 x square cos x dx. We will evaluate this using the integration by parts. So we do first function, the integral of the second minus integral of the differential of the first into integral of the second, and that will be equal to x square into integral of cos x is sin x minus 2 into integral of cos x is sin x dx. Right. Then integrate minus 2 into integral of x sin x is minus x cos x plus integral of cos x. Again we have used integration by parts, and we got this one. Now evaluate the limits from 0 to pi by 2. This is all integration we have seen, and at the end we have taken the limits. Right. Now x square, that is for the upper limit, pi by 2 whole square into sin pi by 2 is 1, minus 2 into cos pi by 2 is 0, sin pi by 2 is 1 by 2. So minus 2. So you will get pi by 2 whole square minus 2. For the lower limit, everything is becoming 0, because sin x is 0, cos x is there 0, sin x is 0. So the integration, the value of the integral 0 to pi by 2 x square cos x dx we have shown you here, and it is equal to pi by 2 square whole square minus 2. It is given to be pi by alpha whole square minus alpha, right? For some alpha he said. So now comparing the terms, then you will get alpha is equal to 2. Now that is the answer. The answer to this question is 2. That is the detailed discussion of this question, and it is a little lengthier, and working out in an examination it will take little time. Otherwise it is an easy question. Let's now move to the next question. This question has appeared in the JEE Main exam held on 29 January 2024 in the second shift. The given question is, if integral pi by 6 to pi by 3 of under the square root of 1 minus sin 2x dx is equal to alpha plus beta times root 2 plus gamma times root 3, where alpha, beta, gamma are rational numbers, then 3 alpha plus 4 beta minus gamma is equal to. Right. Let's now discuss the solution of the problem in detail. Right. Integral pi by 6 to pi by 3 of under the square root of 1 minus sin 2x dx. For sin 2x we have written 2 sin x cos x. For 1 sin square x plus cos square x. This is not minus, this is plus. This is plus. There is a mistake, typographical error is there. So that is an integral pi by 6 to pi by 3 sin square x plus cos square x minus 2 sin x cos x is sin x minus cos x whole square under the square root. Now this is integral pi by 6 to pi by 3. This comes out as mod sin x minus cos x dx. Now observe that in the in the interval pi by 6 to pi by 4, sin x is greater than cos x. From pi by 4 to pi by 3, cos x will be bigger than sin x, and that is why we written cos x is bigger than sin x in the interval pi by 6 to pi by 4, yes, plus sin x is greater than cos x in the interval pi by 4 to pi by 3. I am sorry, earlier I said cos x minus sin x, it is cos x is greater than, I said it is sin x. Sin x is greater than cos x in the interval pi by 4 to pi by 3. This is evident from the graphs of sin x and cos x. You draw a very rough graphs and find out this one. This is easier. Now integrate. So integral of cos x is sin x, integral of minus sin x is cos x, between the limits pi by 6 to pi by 4, plus integral of sin x is minus cos x, integral cos of minus cos x is minus sin x, pi by 4 to pi by 3. Right. For the upper limit, for the lower limit of the first bracket, for the upper limit of the second bracket, for the lower limit of the second bracket. And you know sin pi by 4, cos pi by 4, 1 by root 2, sin pi by 6 is root 1 by 2, cos pi by 6 is root 3 by 2. Those values you go on substitute. Now minus 1 by 2 minus 1 by 2 is minus 1. 1, this is 2 by root 2, this is 2 by root 2, the total is 4 by root 2, that is 2 root 2. This is minus root 3 by 2, minus root 3 by 2 is minus root 3. Therefore minus 1 plus 2 root 2 minus root 3. This is given to be alpha plus beta root 2 plus gamma root 3. Comparing the terms, alpha is equal to minus 1, beta is equal to 2, gamma is equal to minus 1. Now we want 3 alpha plus 4 beta minus gamma, 3 times minus 1 plus 4 times 2 minus gamma is plus 1. Simplifying, we will get 6. The answer to this question is 6. And that is the detailed discussion of this given problem, and it is definitely an easy problem. Let's now move to the next question. This question has appeared in the JEE Main exam held on 29 January 2024 in the second shift. Let the slope of the line 45x plus 5y plus 3 is equal to 0 be 27r1 plus 9r2 by 2 for some r1 r2 belongs to R, that is set of real numbers. Then limit extends to 3 of the definite integral 3 to x 8t square by 3r2x by 2 minus r2x square minus r1x cube minus 3x with respect to t is equal to. Let's now discuss the solution of the problem in detail. We have the given line 45x plus 5y plus 3 is equal to 0. This will imply 5y is equal to minus 45x minus 3. Its slope is minus 45 by 5, that is minus 9. But the slope of the given line is given to be 27r1 plus 9r2 by 2. Therefore, they must be equal. Therefore, we'll get 27r1 plus 9r2 by 2 is minus 9. Right. Keep this aside. Now, limit extends to 3 integral 3 to x 8t square by 3r2x by 2 minus r2x square minus r1x cube minus 3x with respect to t. Observe that the numerator is only the function of t and the denominator is free from t. Therefore, limit extends to 3 of integral 3 to x 8t square dt by the denominator as it is. Now, as the limit extends to 3, integral 3 to x d 8t square dt will become integral 3 to 3. The integral 3 to 3 is 0 by, this is also 0 as x tends to 3. That is, wherever there is x, is just substitute 3 because it's a polynomial, it's continuous. Therefore, you can substitute x is equal to 3 here. Let's look. Is it 0? Is it 0? Is it 0? Just substitute. Then you will get 9r2 by x minus 9r2 minus 27r1 minus 9. Simplify. You will get minus 9r2 by 2 minus 27r1 minus 9. This is from here. Send this to the other side and you will get 0. Therefore, this is also 0. 0 by 0 form. Use L'Hopital's rule. Right. Limit extends to 3. Integral of the numerator is 8x square. Right. By integral of the denominator 3r2 by 2 minus 2r2x x minus 3r1x square minus 3. Right. Now, limit extends to 3 if you take 8 times 3 square by substitute x is equal to 3 in the denominator. It's a polynomial again, so it's continuous. Therefore, just substitute wherever there is x the 3. So, substitute it and simplify. You will get 72 by minus 9r2 by 2 minus 27r1 minus 3. Now, observe that 9r2 by 2 plus 27r1 is minus 9. So, minus 9r2 by 2 minus 27r1 will be 9. So, it is 72 by 9 minus 3, that is 6. 72 by 6 is 12. So, the answer to this question is 12. And that is the detailed discussion of this problem. And it is definitely very, very easy question. Let's now move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. Now, the question is the value of 9 times integral 0 to 9, the greatest integer of under the square root of 10x by x plus 1 with respect to x, where bracket t denotes the greatest integer less than or equal to t is. Let's now discuss the solution of the problem in detail. 10x by x plus 1 is sitting under the denominator. Now we ask the question when it will take under the square root of that will take an integer value, provided that will be a square of an integer. So 10x by x plus 1 is equal to 1 square or 2 square or 3 square. Why we have stopped at 3 square? It will be evident afterwards. Right. 10x by x plus 1 is equal to 1 square. That will imply 10x is equal to x plus 1. That will imply x is equal to 1 to 9. So 10x by root of 10x by x plus 1, the value will lie in the semi-closed interval 0 to 1 for all x belongs to the semi-closed interval 0 to 1 by 9. Therefore, the bracket of under the square root of 10x by x plus 1 in this interval is 0. So take the next one. 10x by x plus 1 whole square is equal to 2 square. That is 10x is equal to 4x plus 4. That is x is equal to 2 by 3. So under the square root of 10x by x plus 1 will belong to the semi-closed interval 1 to 2 for all x belongs to the semi-closed interval 1 by 9 to 2 by 3. And the bracket of under the square root of 10x by x plus 1 will be 1. That's the greatest integer in that interval. Right. It will not be 2 because it is not included. Right. Now 10x by x plus 1 is equal to 3 square will give you 10x is equal to 9x plus 9x is equal to 9. You have to stop here. Why? Because the domain of the interval range is 0 to 9 and we have reached x is equal to 9. Stop there. Don't need to go further. So this will be under the square root of 10x by x plus 1 is the closed interval 2 to 3 for all x belongs to 2 to 3 to 9. Right. And therefore the bracket of under the square root of 10x by x plus 1 is 2, the greatest integer. Right. So now we go to the integral and break the interval into those intervals. Right. So the break now, how do we break? 0 to 1 by 9 and 1 by 9 to 2 by 3, 2 by 3 to 9. So we break 9 times of integral 0 to 1 by 9, 1 by 9 to 2 by 3, 2 by 3 to 9. In the interval 0 to 1 by 9, the greatest integer is 0, 0 times dx. In the interval 1 by 9 to 2 by 3, it is 1 dx. In the interval 2 by 3 to 9, it is 2 dx. So simplify 9 times integral 1 dx is integral, that is x under the limits 1 by 9 to 2 by 3, 2x, 2 by 3 to 9. Now for the upper limit 2 by 3, for the lower limit minus 1 by 9. For the upper limit 2 times 9 18. For the lower limit 2 times 2 by 3 minus 4 by 3. Simplify. You will get 9 into 155 by 9. 9 cancels. You will get the answer 155. Thus we got the answer to this question is 155. And that is the detailed discussion of this problem. And it is also an easy question. Agreed. And in this video, we have discussed 4 questions out of the 10 questions that were asked in the JEE Main exam in the January 2024 session from the section Definite Integrals. I am sure that you have understood the solutions of these 4 problems. I make an appeal to all of you. Please like, share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.